Okay, so now we're going to apply what we've already done to different functional groups. So alcohols and ethers are often grouped together because they have an oxygen that is singly bonded to the carbon chain. So when we do aldehydes and ketones, it'll be a C double bond O. Okay, so when you do the different families or functional groups, then there's slight differences, but sometimes, like these ones, they are kind of clumped together based on the bonding. Okay, so alcohols have OH. Ethers, so this is very fancy. Two alkyl groups, which is basically two carbon chains. They can be the same length, they can be different lengths. We saw the use of R yesterday as like a chain, some kind of carbon chain. So then they're using R and R prime to say it's two carbon chains. But it doesn't matter how long they are. It doesn't matter if they're the same or not. The big thing is that the oxygen is in the middle. It cuts them in half, okay? The oxygen is not at the end. It's in between carbons. So that's going to affect how we name it, and it's going to affect their properties. So alcohols and ethers, we consider them to be structurally similar because they have that single bonded oxygen, and they are derivatives or come from a reaction that involves water. So again, that is a very common reactant or product you're going to see in organic reactions. So alcohols are very ubiquitous molecules. Now, again, we sort of unfortunately use the word alcohol in an incorrect sense. So whether you're talking about wine or hard alcohol, the alcohol in beer, all of that is actually ethanol, okay? So the term alcohol does not imply different kinds of spirits, for example. It's everything is ethanol with just different additives to it. So when you have something like methanol, which is one less carbon, that'll actually make you blind. So let's say I worked at SC Johnson that had industrial ethanol. If you work in a place with industrial ethanol, it came in this huge vat. It had its own room. We had to, every time you took some of it out, you had to write it down, but they also put methanol in it. Or when you go to university and you take labs that have to be really sterilized, like microbiology and stuff, you'll use ethanol to clean, and they often put methanol in it because it will make you blind. So, and then people are like, well, why do we drink alcohol? It's a very good question. So even one more carbon ethanol, it's not like it's good for you. You feel drunk because it is destroying your cells, right? When you vomit it up, it's because it's like, your body's like, no, get this out of me, okay? So it's not that it's good for you, it's that your body tolerates it. Propanol, one more carbon, that is rubbing alcohol. So you think about it, what do I do with that? Oh, I sterilize and get rid of coronavirus, and I sterilize cuts. So it's literally killing things that you don't want. So even though ethanol is the alcohol in whatever, beer, wine, whatever, it's still, like I said, your body is only tolerating it, okay? So it's not that it's good for you. But, so be careful, there's always, stupid TikTok challenges or whatever. If somebody is drinking something like rubbing alcohol or isopropanol, or if they're going to drink, hand sanitizer or whatever, there's often other additives to it, so to make it undrinkable, so to speak. Okay, so please don't do that. Okay, and don't encourage others to do that either. Okay, so the good news is with these names, except ethers actually, but aldehydes, ketones, alcohols, they all have, it's sort of in their name already. Alcohol ends in OL. When you have an OH group, the ending is not going to be E anymore. We're going to change it to OL. We don't say methyl, okay? We say methanol. So we keep the AN part, but we drop the E and add OL. Methanol is the simplest. There's only one carbon. But once you start to add carbons to the chain, then you have to say where the alcohol is. So this is on carbon number 1. So this is 1 propanol. So 2 propanol. However you decide to, if you do condensed or whatever, is on carbon number 2. If you're a stick person, just put the OH at the end of the stick. If you're not a stick person, that's fine. Don't feel like you have to be. When we do reactions, the placing of the OH group is going to matter. So then we get 3 basic types of alcohols: primary, secondary, and tertiary. And we're going to, compared to some of the other functional groups, we're going to talk a lot about alcohols because they are so ubiquitous. And actually, when we do the labs, we can use alcohols. Should we drink them? No, but they're also not toxic enough to, like, make the entire bottom of the floor smell like vomit. Okay, so they're actually pretty useful. And obviously, as humans, we make use of them. We burn them. We clean cuts with them. Yes, we have fun with them, whatever, right? So alcohols are everywhere, so they're really well studied, okay? So a primary alcohol, sometimes people think of it like the OH is at the end of the chain, which is okay for primary, but then secondary and tertiary, this definition at the bottom works a little bit better. So try to focus on how many hydrogens there are attached to it, which when we do the reactions, that's going to affect how reactive they are, okay? So pick a chain however long you want it. So say we'll do 4. So then the carbon that is attached to the OH has 2 available hydrogens. So I'm just going to emphasize those, okay? It doesn't have to be butanol, but that's the example there. So yes, for primary, it has to be at the end of the chain. But when you get to secondary, even though the term second sort of implies it's on the second carbon, if the chain was longer, it could be on carbon 3 or carbon 4, okay? Here, if we're going to continue with butanol, it would definitely be on the second one. You can even underline if you want. So 2 available hydrogens, 1, 2. 1 available hydrogen, 1. And then tertiary has no available hydrogens. So all of these have 4 carbons, right? They're all isomers of butanol. Just the placement of the OH is different. So now, when there's no hydrogens attached here, that means that nothing can be lost. So we're going to see when we do aldehydes and ketones, this is a very unreactive alcohol. Except combustion, of course. It always will burn. Sometimes, yes, sorry, Lauren. So prop is the longest chain. And then on number 2, there's a methyl. And you have to say where the OH is now. Okay? So if you prefer that dashed ending, like you can do this way too. And then the 2 is with the OL. You can do that. If you don't like this, then don't feel like you can do this. Okay? Oh, and there's also short forms, again, in math even, and biology. So you might see this to mean tertiary, like 2 naught, it's called. This to mean secondary, and this to mean primary. Just in case you see those, scientists are lazy. We love short forms. But again, those are like maths, biology, all across. Okay, so you can have more than one alcohol. So again, to say like if there were 2 alcohols, you would use di, tri. But really, what's most important is the number of where the alcohols are. So the numbers are the most important. They show on the chain where the OHs go. And I snuck a little chloro in there. You can have other stuff on there as well. So if you want, start with the 7, the hept. Decide how you want to number. And now that we've got a bunch of things on here, it might be maybe you really do want to label like 1, 2, 3, 4, 5 or whatever. So I'm gonna start from the left, but you don't have to. Yes, this is 5, 6, 7, but I don't need that. I'm only gonna do 2 and 4, right? So chlorine 2 has a carbon 2 has a chlorine. It also has an OH, so usually we draw 1 in the top, 1 in the bottom. You could have put the OH at the top and the chlorine at the bottom. That doesn't matter. Then you go to number 4. It also has an OH. Okay? And then we just fill in the rest with ticks. If you're a condensed person and you can see that this would be CH3 and then you want to draw the rest out, you do what you prefer. Let's see. Maybe you're a stick person. Sorry, my condensed got extra condensed there at the end, but you can pick what you like. Yes, Simon, sorry. Yes, so technically, yes. But if you forgot that, that's okay. But the numbers, you have to put the numbers in because you have to show where it goes, okay? Where the OHs go, yes. Let's add it in. Let's do it. Then you would do this, like 5-ene. Yeah. Now, again, we try to, like, yes, I could do that in real life. Is that really a thing? No. So usually we don't combine them, okay? Now, if you like to look for yourself and you Google some random teacher's worksheets, can they put that on a paper and pencil task? Of course they can. Okay, so that was a good question, Fiona. Just in case you see it. You can also have alcohols. So cyclohexane is a ring. No double bonds inside. This is not benzene. And then wherever you want, put OH. So there was a question, it was like cyclohexene, I think. Michaela asked me. And your textbook is like, it is good, but sometimes I'm like, oh, you're so unfriendly. They're just, because it's a ring and there's no beginning and no end, they don't put a number. So same thing, like they didn't put 1 cyclohexene. They're just assuming that you know that. So if you want to write the 1, then you can, okay? Because there's no beginning and no end. If you wrote it here, this would be 1. If you wrote it here, here, here. If you turned your hexagon on the side, no matter where you put the OH, it would be number 1. Also, if you did, sometimes they call this hydroxy. As a functional group, like they'll write hydroxycyclohexane, but I've never, that's not really a thing outside of your book. So if you see that in the answers, that just means alcohol. If they were my answers, like it's my handwriting, then I don't usually use that. I hope I didn't. Okay? If you want, I can't remember what the homework has, but there might even be this, which we called phenol. That's its common name, which you don't need to memorize. So again, I forget if they use this in the homework, but they might call this hydroxybenzene. Or you could call it, do the same thing and just change the ending to OL. Okay? All of those are the same. But again, you don't have to memorize that. If you are, into this and you happen to memorize it, that's fine too, but you don't have to memorize it. Okay? So as I was making the flip chart, I realized I made a chart for the ether properties and not the alcohol properties. I don't really know why I did that. So it's not that ethers are more special than alcohols. It's actually the reverse. It's because alcohols have the OH. So whenever we do families, you're looking for, when you talk about properties, OH or NH. Okay? So this is a big deal. So the OH group is quite polar, and they will form hydrogen bonds with water. They also form hydrogen bonds with other alcohols. So if you want, try, I know there's not a ton of space, let's sneak a little picture in, okay? So I'm going to use the number 1. I'll just use methanol, okay? I'll keep the simplest alcohol. Oops, that's not ethanol. Okay, so in the first unit, we talked about hydrogen bonding as the strongest intermolecular force. Yesterday, in the lesson 1, we talked about general properties. So this is now applying it specifically to alcohols, so a specific family. So when you have a strong force, that means it takes energy to get them apart. So when it talks about, again, we usually just use boiling points for organic molecules. So higher boiling points, sometimes melting, means, that's a result of the strong hydrogen bonds. And so there's 2 hydrogen bonds that can form. So some molecules will form them with water, and some molecules will form them with water and other similar molecules, okay? They're not going to do number 2 if they can't do number 1. So this is less unique. This makes alcohol stand out, okay? So, and you guys, maybe you've seen your parents or whatever, like you can put alcohol in the freezer and it doesn't freeze, right? Because the hydrogen bonds are so strong. It takes so much energy to make it change state, okay? So the OH group is quite polar, forms hydrogen bonds with water. I do realize that it would also interact here, but I tried to make my picture as simple as possible, okay? So if these dashed lines, if you want to, we did make note of this last year in the first unit, but if you want to emphasize it there. Same thing over here. I realized this O and this H would also interact, but again, I'm trying to keep the picture as decluttered as possible. And then, so what you're going to see as we go through these families as well, that it always is going to talk about the hydrocarbon chain, okay? And it's sort of a gradient. Hopefully, I'm going to have it set up so that you guys can see the difference between a soluble alcohol and insoluble. And it's not like all of a sudden you're going to see chunks. Remember, it actually looks like oil droplets, like oily. Okay? So it's sort of a gradient. So when anything is small, it is going to be more soluble in water. But then what happens when you start to get a longer chain, then the solubility starts to decrease. And what happens is then you'll see oil droplets. So for our purposes, you're going to see every single time this. 4 or less carbons, okay? So if it's bute or lower, then it's going to be more soluble in water. Once you start getting 5, 6, 7, 8, then you start to see the oil droplets, okay? Usually, so if you look at the quiz review I gave you today, even though there is no quiz, there's a question about like ranking them. Usually we rank them in terms of boiling point because that's a little bit more straightforward. Again, solubility is sort of wishy-washy. Normally it's like nonane, which is just a hydrocarbon. Is it going to dissolve in water? No, because it's nonpolar. As opposed to ranking them, that's a little bit less straightforward. Okay. All right, so we have a bunch of reactions that alcohols can undergo. So again, alcohols are easy to use, in terms of organic molecules. So there's a lot of reactions that they'll do. So I included the combustion example there for you, but remember it's the same thing. You need oxygen, you're going to get water and carbon dioxide. We're only going to write reactions for complete combustion. Now, alcohols burn so readily that usually it actually is complete combustion. And then the addition reactions, so again, usually more often it's an alkene than an alkyne, but I did sneak that in there in brackets. And what you do is you add water, and then the water is going to contribute the OH group, and that's how you get an alcohol. So this, in the summary chart, and again in your textbook, they call it hydration. Which is specific, and that's fine, but you guys don't have to be that specific. But hydration is good because if I asked you guys to hydrate yourselves, what would you do? Add water, right? Okay. So let's pick an alcohol. Adding water, which is HOH, is going to be subject to the Markovnikov's rule, okay? So again, when you add water, or whenever we deal with water, even when we get to acid-base equilibrium, try to think of it as HOH. Let's do, what example do we want to do? You know what, I'll just do propane again. Christmas colors. Okay, so we're going to follow Markovnikov's rule. So again, you're looking at these two carbons here, the ones in the double bond. Which one has more hydrogens? The first one. And unless the question specifically asks me for the minor product, you just follow the rule, okay? I'm not even going to worry about it here. Okay, so remember, it's going to be complete. It'll be water and carbon dioxide. You just have to balance it. When you do a combustion reaction, if it asks you to draw and name the reactants, that's fine. But then because you have to balance these and they're a little bit annoying to balance, you might want to rewrite them then with the formula. Whereas all other reactions, we don't write the formulas at all. Okay, so but combustion, because you usually have to balance them, then maybe that's a little bit easier for you. You're good? Okay. All right, so substitution. So the alcohols can actually do substitution as well. Okay, so lots of things that you can do with alcohols. So when we're going to do the same thing as before, you're going to switch. Okay, so when you have substitution, 2 reactants and 2 products. I did already include these, so if you want to go over the functional groups, like I'll make this blue, maybe even this one. But really similar to the substitution with alkanes, except this time, now you've got an OH. So again, if you're like, I don't know where to put them, look for the active site. reactive site where the functional group is. Also, what's a really common product? Water. So if we substitute, then this comes off, the H comes off, and you get water. So when in doubt, try to make water, okay? I'm just going to continue to write it condensed. If you don't like condensed, you don't have to, okay? But we're going to do the same thing as substitution of the, with an alkane that you have, you're going to make what we called an alkyl halide. And two reactants, two products. But instead of halogens like Br2, H2, not H2, F2, Cl2, it'll be a hydrogen plus Cl or plus Br because you want to get water. So if you want to remind yourself that the alkyl halide, that's what that is, the carbon chain and a halogen, it's the fancy term for it. In all these examples, or often I've picked like 3 carbons, 2 carbons. They can be longer. Just read the question carefully. Let's say you have a water bottle, and on the outside, you get little droplets. What do we call that? Condensation, right? So changing from gaseous water to liquid water is sometimes called condensation in the clouds or whatever. So often as well, when you make water in an organic reaction, we call it condensation. So yes, you can call this substitution because technically we switched the OH for the Cl, but you can also call these reactions substitution. So when we look at forming ethers, because we're going to make water join 2 alcohols together, then we call that reaction condensation. So could this be called condensation? Okay, so sometimes there's actually more than one name, and the clue is in what kind of products you get. Again, maybe that's not helpful. Maybe you'd rather just have substitution, but you can have both. So I don't know why. In your note, there's a line, but I didn't really make ethers a title. So if you want to, like you guys have a dotted line, but then the rest of the note has to do with ethers. I didn't really make that very clear, sorry. So ethers have, they're a little bit different than an alcohol. They have the O, but they don't have an OH, okay? So they have an oxygen in between carbon chains, okay? So when you name them, we're going to consider each chain separately. And again, we're going to try to keep this as practical as possible. So it says step number 1, choose the longest alkyl group or the longest carbon chain as the parent. That's what we've done before. It says alkanes because there aren't double bonds in ethers, okay? So this is the same rule as before. Give it the alkane name, the longest chain. Now, they can be the same, which makes your life easier, okay? But here, this side has 2 carbons, this side has 3. And it doesn't matter which side is which. So then 3 is longer than 2. So we're going to call this propane because it's the longest. So then the shorter chain, you're going to use oxy. So let's say this wasn't here and it was a branch, you would call it ethyl. So it's saying replace the YL with oxy. Basically, you count carbons. Oh my goodness. So for the shorter chain, count the carbons and put oxy. So here is 2. What's 2? F oxy. Let's say they were both prop. You would write propoxy propane. That makes your life easier. But so it does follow some of the principles from before. The longest chain gets to be the parent, so it goes at the end. And then the shorter chain, we're going to just count them and put oxy. So it's like 2 carbons, oxy, 3 carbons. Sometimes you might have, again, I think the homework's pretty straightforward because ethers, generally speaking, are not too fancy. If you had like a chlorine on here, then you would write it in front of the propane part, but that's not really a very common thing. Good. Okay. So now that you only have a CO bond that is not as polar as the OH, so an ether is less polar than an alcohol. Now, trying to rank polarity like that is super tricky, okay? We're not really going to do that. What we'll do is more things like this, okay? There is no OH bond, so then hydrogen bonding does not occur between ether molecules. So the only thing they can do is accept hydrogen bonds from water. So if you want, in this little spot, Um, Draw in, this is the simplest ether, methoxymethane, and then it would hydrogen bond with water, but not with other ethers. So then their boiling points are much lower because the alcohols can hydrogen bond with other alcohols. Ethers cannot do that. They don't have O and H, only O. So again, when you have a small carbon chain, then they're going to be soluble in water, and then the solubility decreases as the size increases. So very similar properties. It's all about what kind of intermolecular forces can they form. Does an ether have OH? No. So even if you want, it is down here, but an ether does not have an OH bond, okay? It does have an O, but no OH. Okay, so to make an ether is going to be a condensation reaction. So again, if condensation formed, you'd be like, oh, water's forming, right? So here, I picked the H from this one and the OH from this one, but it's not like the ethers say to each other, okay, I'm going to give my H and you give your OH, right? It doesn't really matter. I just picked it. So if you want, highlight this somehow or whatever. So one of the carbon chains needs to keep its O. So I've chosen this first one. Okay, and then it's going to join with the other carbon chain. And the other product, HOH, water, again. So for alcohols and ethers, the questions, it's all combined now. So name and draw and reactions. There's two parts on page 48. So one of them is practice questions, like there'll be a box of practice, and then one of them will say section 1.5 questions. Okay, so that's a little bit different. And the solutions, I think they're in two files. I don't know why I did that, but it's underneath the alcohol and ethers questions. It's the same format as the other ones. When after lunch, then